How do we find the inverse of a function algebraically? Well, in this example, we have a linear function, f of x equals negative 3x plus 10. First thing I would like to do is swap up my notation. So rather than going with my function notation, I'm going to switch it to an output variable, a single output variable of y. So that's my first step, which will then make it easier for me to do my next switch, which is the big basic inverse function switch of changing the inputs and the outputs. So we switch the input variable with the output variable, giving me x equals negative 3y plus 10. And then finally, we solve for y. So we're looking to get y on its own. So what I will do is first subtract 10 from both sides of this equation. The 10's cancel out. X minus 10 cannot combine, so it's simply x minus 10. We rewrite everything else equals negative 3y. Then, last piece, I am dividing by negative 3. Remember, I must divide everything, not simply the x or the 10, but both. And then my negative 3's cancel out, so I get x minus 10 all over negative 3. I can then pull my negative to the outside of this, and that will be fine. And then finally, I tend to like switching my position of my y with the rest of my equation. I like to switch them up just because it looks neater to me, but I'm going to also replace y with function notation. Now to indicate the inverse, I do f inverse of x, and the inverse is indicated by raising to a negative 1 power, quote unquote, equals negative x minus 10 all over 3. And there we have our inverse function. So, looking at everything all together, my initial function was f of x equals negative 3x plus 10, and my inverse function when I look for it algebraically is f inverse of x equals negative x minus 10 divided by 3.